In this video we are going to study binary system, and before starting binary system we need to remember exponential notation. You know this topic from the primary school, but maybe first time in English. A to the power of m is exponential expression, means a multiplied by itself a m times. A times a times a, it's going to be equal to a to the power of 3, a to the power of 3, or 3 times 3 times 3 times 3 times 3, 3 multiplied by itself 5 times, so this is 3 to the power of 5, it's going to be. This expression is called exponential expression. The number 3 is called base, the number 5 called exponent or power. When we read the expression a to the power of m or 3 to the power of 5, here we are going to read like this, and whole expression is called exponential expression. Here there are some simple rules that we need to remember also. Number to the power of 1 is equal to number. So if we are using 4 to the power of 1, the result is going to be equal to 4, or 5 to the power of 1 minus 5 to the power of 1 is equal to 5 minus 5, and when the power is not written, we are going to understand that the power, it must be equal to 1, or 3 is equal to normally 3 to the power of 1, because when the power is not written here, we are going to understand that that power is going to be equal to 1. Okay, then second rule is number to the power of 0 except 0, also that's mentioned in the third part, and 3 to the power of 0 is equal to 1, 5 to the power of 0 is equal to 1, minus 2 to the power of 0 is equal to 1, it's going to be. And here the last one is 0 to the power of number is equal to 0 except 0. The number what is written as a power cannot be 0 to the power of 0, because it is undefined and it's written here. Okay, so except that one, 0 to the power of 3 is equal to 0, 0 to the power of 4 is equal to 0, or 0 to the power of minus 7 is equal to 0 going to be. Okay, so here there are some practice problems. I'm going to quickly solve what are they, and some of them only. 2 to the power of, this is 1, 2, 3, 4 times, so this is 2 to the power of 4. Here 1, 2, 3 times, so this is 3 to the power of 3. And the last one, the others, they are going to be exercise for you. 1, 2, 3, 4, 5, so this is 10 to the power of 5. It's going to be, so by exponential way I have written here. I said this is the last one, but maybe this one also we need to mention, because this is the rule part. This is 7 to the power of 1. When the power is not written, or when it is only one number, the power it must be equal to 1. Find the value of following expression. It says, I'm going to write only the first one, the others they are going to be homework for you. We are going to solve this one in the class. So 3 times 3 times 3 times 3 times 3, it must be 3 times 3, 9, 3 times 3, 9, and 9 times, because here the multiplication sign we have, 9 times 9 is equal to 81. 81 times 3, this is the last one, and 81 times 3, it's going to be equal to 243. Now we are continuing with the expanded notation in the decimal system. In daily life we are using numbers and we are using in decimal system, but we don't know actually this one, how we are using, maybe we didn't recognize before. But the numbers can be written as a power of 10, like 343 example 47 exercise given here, and here it can be written as a power of 10, and we are starting always with 10 to the power of 0, then 10 to the power of 1, and 10 to the power of 2. As you see, the powers are increasing, 0, 1, 2. If there is another digit, the power must be 3. And 10 to the power of 1 times 10 to the power of 347, 10 to the power of 0 times 7 plus 3, 10 to the power of 1 times 4 plus 10 to the power of 2 times 3. It's going to be, actually the number is written here, 347, only multiplied by 10 to the power of 0, 1 and 2, and the order is 0, 1 and 2, and I didn't miss any number, 0, 1, 2, 2 it's going to be. And let's write the results here. You know 10 to the power of 0 is equal to 1, 1 times 7, 10 to the power of 1 is equal to 10, 10 times 4, and 10 to the power of 2 is equal to, it's equal to 100, 100 times 3, and 1 times 7 is 7, 10 times 4 is equal to 40, and 100 times 3 is equal to 300, and the sum again it's going to be equal to 347, which means number is written in terms of decimal system, expanded notation in decimal system. Now I'm going to solve only one exercise, the others they are going to be homework for you. 7964. 7964, this is 4-digit number, and I'm going to write here as I made before. Here arrows I'm going to use like these are, and units multiplied by 10 to the power of 0, tens multiplied by 10, and here this is 10 to the power of 2 hundreds, and this is going to be thousands, and 10 to the power of 3. The order is going like that, 0, 1, 2, 3, the powers I'm talking about. So times the numbers, digits, 4 times 6 times 9 times 7, and here from the beginning if I write in decimal form the 7,964, if it is written in decimal form, 7 times 10 to the power of 3, it must be 9 times 10 to the power of 2 plus 6 times 10 to the power of 1, and the last one it's going to be the last one, 4 times 10 to the power of 0. And this is expanded notation. This part is expanded notation. Expanded the notation of 7,964. I forgot for this one. Here the number 347 is equal to 347 is equal to 3 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus 7 times 10 to the power of 0. It's going to be, okay, what is binary system? Binary system is the notation for the, especially we are using for the computer. That's why I have this picture here. And we are using this counting system in computer calculations. Normally when you give the number, when you write the number, when you type the text, it's converting that text into binary system. It's coding with 1 and 0s only. It's using only 2 number, 1 and 0, and everything what we are writing coded, it's coding to, computers are coding to binary system. So when we have given a number like this, 1 1 0 1 and let's say 1, and I told you at the beginning, if you remember, computers are using only 2 numbers, 1 and 0, so all the number made up this 2 number. And if I write here 2, I'm understanding this system is base 2. And like in the previous one, in the decimal system, when the number is given here I'm understanding this is decimal system. Normally I have to mention maybe this is base 10, here also the base 10, and that's why all the numbers multiplied by 10 to the power with numbers. Here this is in base 2, all the numbers must be multiplied by the 2 to the power of something. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and this is 2 to the power of 4. It's going to be, as you remember from the previous page, 0, 1, 2, 3, and 4, the powers are continuing in order, and we didn't miss any number here. Also, we didn't pass to 3 directly. We are writing the numbers in order. Then, like in the previous one, how I wrote the numbers 7, 4, and 3 one by one. Here the numbers maximum can be 1, and I have to write from left to right again, actually right to left, from this side to this side. 1, then 1 again, and then this is going to be 0, and this is going to be 1, and this is going to be 1 again. And as you see, the number here, what is stored with 11011 is equal to, when you find the results here and when you add them up as we made here, we are getting always the same number. In decimal system here, if you remember from this page, when we add them 7 plus 40 plus 300, we found 347 again. Back, we turn back, and here we are going to do the same thing. 2 to the power of 0 is equal to 1 times 1, which is equal to 1. 2 to the power of 1 is equal to 2. 2 times 1 is equal to 2. 2 to the power of 2 is equal to 4 times 0 is equal to 0. 2 to the power of 3 is equal to 8 times 1 is equal to 8. And 2 to the power of 4 is equal to 16. 16 times 1 is equal to 16. So the result it's going to be, when you find them, 1, 2 plus 8, it's equal to 11. 11 plus 16 is equal to 27, it's going to be. And this is the number in base 2. And this is the decimal form of the binary system of a number. So I convert from decimal number to I convert from the binary system to decimal number. Here we have some exercises. I'm going to solve only B and C one. Actually, this is the same, because this is 2 to the power of 0 times 1, it's going to be, which is equal to 1 times 1, and that's equal to 1 again. So 1 is same in every base. 1, it's going to be equal to 1 in base 10 also. And if it is 101 in base 2, it means that I'm going to multiply by the powers of 2. So 2 to the power of 0, 2 to the power of 1. I'm going to write 2 to the power of 1 and 2 to the power of 2. I didn't miss any power, as you see. Here, this is going to be here and here. And I'm writing the numbers here, digits actually. I'm writing the digits. Here 1, this one is written here, then 0 times 0, then this one is written here times 1. And it's equal to 2 to the power of 0 is equal to 1. 1 times 1, 2 times 1, 2 times 0 actually, and 4 times 1, that's equal to 1, 0, 4. When you add them down, here it's going to be equal to 5. So 5 in base 10, it's equal to 101 in base 2 in binary system. And I'm going to do the next exercise. Actually the number is like this, 1110 in base 2. What is in base 10? We are going to find what is in base 10. Actually this part is going to be 10. Okay, here then firstly we are going to write, if you remember, the powers of 2, and if there are 4 numbers here, it's going to be equal to, it's going to start with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Then times is, I'm writing the times notation, then I'm writing the numbers. This is 0, this is 1, and this is 1 again, and this is the 1 again. And here it's going to be equal to, 2 to the power of 0 times 0 is equal to 2 to the power of 0 times 0 is equal to 0. 2 to the power of 1 is equal to 2 times 1 is equal to 2. 2 to the power of 2 is equal to 4 times 1 is equal to 4. 2 to the power of 3 is equal to 8 times 1 is equal to 8. So the answer is going to be equal to 0 plus 2 plus 4, 6 plus 8, it's equal to 14. So 1, 1, 1, 0 in base 2, it's equal to 14 in base 10 in decimal system. By the way, instead of this one, we can write only 14. There is no need to write always the base 10. So if you write like this, it won't be mistake. This is important part. If you write it like this, it is not mistake, because when there is no number here, we are understanding the base is 10. Okay, now we are going to convert to the other side, but I want to use, before then these exercises, I want to use the previous one, the number 14 in base 10, what it is in base 2. Actually, I know from the previous page, and if you remember, the answer in base 2 is equal to 1, 1, 1 and 0. If you remember the previous page, let me show here again, and the result is equal to 1, 1, 1 and 0. Here this was 5 and this is 14, if you remember. Here this is the last exercise, and this is going to be the homework, by the way. Okay, now I know that is 1, 1, 1, 0 in base 2. So how to get this number from 14? With this exercise, we are going to understand that one. Firstly, we are using division form for this number. We are dividing always by 2 because we are converting into base 2. So when it says base 2, it means that divide by 2. Always divide by 2 till it is not possible. I'm going to explain what does it mean. Now when you divide 14 by 2, it's going to be equal to 7. 7 times 2 is equal to 7 times 2 is equal to 14, and the remainder is equal to 0. I'm going to use different colors to explain the different numbers. Here the remainder is, remainder is 0, the quotient is 7, but 7 is divisible by 2, so I'm going to continue to divide the expression. So the quotient number is important for us. If it is divisible by 2, you should continue. The quotient is 7, and it's equal to, when you divide by 2, it's equal to 3. 3 times 2 is equal to 6, and the remainder is equal to 1. I'm writing with different color because the numbers are important for me, the remainders are important for me. And now I'm going to divide by 2 again, as usual. And when I get the here, it's going to be equal to 1 times, and 1 is not divisible, so this is the last quotient that I found. 1 times 2 is equal to 2, and the result is here. It's going to be equal to 1, but I don't want to write the quotient with different color, because here I want to write the quotient with different color because the order is important. Now when you're writing 14, as you see the remainders, 1 1 0 1 1 1 and 0, which is these are the group of numbers here. I'm going to start from the back. 14 in base 10 is equal to 1 with white 1, then the blue 1 1, then the yellow 1 1, then the green 1, and it's equal to 0 in base 2. Actually, if you understand here, the order, it starts from the quotient and it takes all the remainders, and 1 1 1 0 order continues like that, and we are finding the decimal number in binary form. And here another decimal number 44. I'm going to do the same exercise. 44 divided by 2, the result is 22. 22 times 2 is equal to 44. The remainder is equal to 0, so this is the last digit. Then by 2 divided by 2 again, 11. 11 times 2 is equal to 22. The remainder is again 0. And divide by 2, it's equal to 5. 5 times 2 is equal to 10. And the remainder is equal to 1 now. 5 divided by 2, the result is 2. 2 times 2 is equal to 4. The remainder is equal to 1. And 2 divided by 2 is equal to 1. 1 times 2 is equal to 2. And the remainder is going to be equal to 0. So 44 in base 10 is equal to 1. Again, I'm writing from this side to this side we are going to go, then this number, then this number, then this number, and this number is going to be so 1 0 1 1 0 and 0. It's going to be in base 2.